Hello, and a very good day to you, sir. Hope you're doing well in this MCU period. My name is Leonard Rubin. My metric number is B0818100388. Today, I'm going to demonstrate about my simulation program. The title of my project is Door Security. This door security can be used in mostly malls, supermarkets, and any outlet-based shops. This project consists of microcontroller, 3 inputs and 4 outputs. The 3 inputs are PIR sensor, keypad, dial, and switches. Whereas for the output, it is the LCD display, motor representing the door, LED lights, and a buzzer. So let us move on and look at the overall flowchart of this project. So this is the flowchart of this project, and this is the block diagram of this project. This is the input and this is the output. And as for the circuit diagram, this is the circuit diagram. So LCD screen, LCD display, microcontroller, PIR sensor, LED lights, motor representing as the door, buzzer, keypad, resistors, and switches, and not forgetting the toggle switch. The function of the toggle switch is to toggle the input of the PIR sensor. When the toggle switch is turned to high, the PIR sensor reacts to the input, and when it is low, it reacts to the input also. Now, let us move on to the coding of this project. And before that, let me explain to you the overall process of this project, this door security. This door security is invented for this supermarkets or any outlets. So during working time, maybe it is from 10 a.m. to 10 p.m. PIR sensor will be inactive. So customers who are going inside or outside of the door uh, will be sensed by the PIR sensor, and the door opens. After operating time, maybe after the shop is closed, PIR sensor will not be able to work, and the working mechanism is controlled. The working mechanism is controlled by the switch, and only authorized person will be allowed to go inside the mall or shop or any outlet through typing it their password, the authorized password, which is given allocated to them. Besides, during maintenance or any troubleshooting time, another switch will be active to shut down the whole system, and maintenance or any troubleshooting problems can be done during that time. So as for the coding, first we have to include all the libraries used. As for the keypad, LCD, motor, and these are the pins connected to the Arduino 11, 9, A3, A2, A1, and A0. And besides, we have to also declare the other pins also connected to the Arduino, buzzer, PIR sensor, and switch connected to pin 12, and switch 2 is connected to pin A4. As for the switch connected to pin 12, this controls the PIR sensor, the working of PIR sensor, whether to shut down or to open. And for switch 2, this controls the all over system, to shut down the whole system or to not shut down the whole system. Now we are declaring all the variables used in this program. This is the password, as I mentioned. Uh, there are 6-digit password, and we can add in or we can minus out the passwords. This is the name allocated for each password. As for the first password, 1234566, the owner of the password is Mr. Raju. Abu is for 22222, and it continues. And this is the declaration of the keypad by rows and columns. And this is the pin connected in Arduino 5432 and 887 and 6. Besides, we also have to declare the output and input of this whole system. As for switch, both the switches are considered as input, buzzer output, PIR sensor input. And for the both the switches, when the switch is open, it is considered as open actively high. And when the switch is closed, it is considered as actively low. When the simulation starts, the screen starts to print initializing. Please wait. Now we can start using our simulation. As I mentioned earlier, the switches during open state it is actively high, and during closed state it is actively low for both the switches. We have three modes used in this, three conditions used in this simulation, which is mode 1, condition where switch 2 it is actively low, where it controls the all over system. The first switch it is considered as mode 3, condition 3, which controls the activation of PIR sensor or not. And mode 0, where both the switches are considered open actively high, where the PIR sensor will be working. As for mode 1, condition 1, it is used, the switch 2 will be actively low, which is closed, and the LCD will print out shutdown for maintenance, or we can edit for any other messages we want to give out. This switch can only be used to shut down the whole system or to perform any maintenance or troubleshooting problems. As for mode 3 or condition 3, switch 1 is actively low. So this controls the PIR sensor, the working of PIR sensor. When this switch is actively low, PIR sensor will not be able to use, where the entry of this door through this door can be only done by authorized person by entering the password through the keypad. As for mode 1, both the PIR sensor and the keypad will not be able to use. And for mode 0, it is a normal mode, normal operating mode. The LCD prints out normal operating mode because both the switches are actively high, uh, where it is open in the as for the real simulation. At this mode, a PIR sensor will be working, and the PIR sensor will sense the movement of any objects or any people, and the motor will start opening. For mode 0, PIR sensor will be actively high, and the LCD will print out welcome, and the door will open. So this is a function call. So we will look at this function call in below. As for mode 3, as I told you, the PIR sensor will not be able to work, and all the entries should be done through the keypad. So this is the coding for all the keypads and everything. So uh, for each and everybody's name and password should be entered, and all the conditions. So this is the uh, function call for both door opening. This door open will be used during keypad entry, and door open 1 will be used during PIR sensor entry. Besides this, this system is also consists with alarm system where more than three incorrect password is inputted more than three times. When a wrong password is entered, an alarm system will be activated. So this ensures the protection of the stall or shop. Now let us move on to the simulation of this project. So when we start initializing keys with DOS security normal mode, and this is the switch I told you as to will control the PIR sensor, and this is to control the whole all our system. So let us start with this shutdown system, shutdown switch. When the switch is closed, when the switch is open now, it is actively high, and when the switch is closed, it is actively low, and the whole system is would not be working. The PIR sensor will not work. The motor is still closed, and the keypad will not also work. Okay. Now, as for the PIR sensor, when the toggle is switched to high, the motor opens, the LED will light up. The motor remains open because the toggle switch is still open, still in high, and the LCD will print out a welcome message. Welcome. When the toggle switch is actively low, the door will start closing, and this ensures that the motor is closed. And now if we turn this switch into close, which is will be operated after operating hours of the shop or stall or malls, anything, a message will be appeared close, indicating customers or anyone that the shop is closed. So after this time, after the switch is toggled, the only entry through the door is by using keypad and passwords. So now we can use the password and choose Raju security, and the motor will open and close, and the buzzer will sound, and that remains closed. And same goes for all the other passwords. And now as for the alarm security, when wrong password is entered more than three times, an alarm will sound. First, it will indicate wrong password, motor is still closed. Same, wrong password for the second time. This is all a 6-digit passwords. Motor is still closed for the third time. And an alarm system will start to sound. The LED will light up and the buzzer will start sound. This is the overall system, and this is how the whole system will work out. To shut down this alarm, we have to close the whole system, but by not putting this shutdown, but to shut down the whole system, to stop, to fuse out the power. Okay, there are some additions can be made for this system. As for the keypad, it can be replaced to into RFID, because passwords can be always be shared by others or can be known by others if people really intend to know the password. So RFID can be used. RFID is not used in the simulation because Proteus is not we cannot represent RFID in simulation. And as for the memory part, all the entries after the operating hours can be stored inside a memory. So there will be a record. We can go through that who entered at what time and all the activities carried out after that system is closed. And besides, as for the alarm system, we can directly connect through a Bluetooth or any Bluetooth device where the owner of the shop or mall can get instant message when the password or any wrong entries is being uh, carried on. So that's all from me. Thank you, sir.